Hey, welcome, folks. This is our Design 300 lecture for Thursday, October 28th. It's 10 o'clock, and we are on a Google Meet. And this week, again, we're talking about roofing, and we're specifically going over the beams, joists, and rafters. And so last time we went over how to sort of do a material takeoff using Revit. That's kind of a cool thing. We'll talk about our roofing systems a little bit more this time. And I see a lot of you have done the truss material estimate, so that's really, really good work. So let's go ahead and just get into the details. Here's about our roofing systems, and the goal is that you sort of understand rafter and joist construction and roof construction, knowing that on the whole, we're talking about timber, wood, but roof trusses, especially outside of residential, in light commercial and commercial, are often light metal framed or some sort of a rod grid structure or channel. And we have some really cool tools to be able to figure out what the loading is going to be like. And so I think what I'd like to do is show you how that works, and how we can figure out these loads, just so that you sort of know and start thinking about some materials and how they're used, because you have the ability to very easily go through here and do this reading and put that on. So I'm going to go into VMware, and I'm going to use a program called Inventor. And in Inventor, you can make some trusses. And I'm not gonna make a specific truss. I'm just gonna show you the idea and how we can use really good complex computer analysis to make sure that we're getting good information. And you can just know that this has been done for 60 years now. We've been doing these types of computer simulations, but in the last 20 years, they've become common and powerful and really, really good. So I'm just gonna show you the idea behind it without making it a specific truss. So I start out with a part, and I'm gonna do a metal truss. Although I could change it if I know the properties of my material, I can change it instantly to to do that. So here we go. I've got I've got this thing, and I'm going to make what's called a frame. So it's going to be a 2D sketch, and I'm going to put it in my up and down plane, and I don't know, I'm just going to draw a frame, and I'm just going to make lines. And so I'll go at maybe, what was that thing? Maybe 110 inches at an angle of 27.5. And then I'll bring my line straight down. And I can do that mirror thing. It's in here somewhere. There's mirror this object about that. Here we go. And I can come up just a little bit. I'll come up maybe 4 inches. And you know what? I'm going to make that all one member. Now it's all one member, and I can get rid of those little parts that were in there. And I can even trim off this little piece sticking down. There we go. So that's a super basic truss, but then we saw that there were some other ways to do it. And I don't really, I'm just not doing anything in particular. But now you can see that I'm building up something that sort of looks like a roof truss. There. There's my roof truss. That's what it looks like. And that's just the outline of it. And I'm going to save it. I'm going to save that as, and I got to find it. So in Inventor, I go through a bunch of steps because it lets you do so many different things. This is going to be my truss outline. Truss outline. That's cool. So now I'm going to do a new thing. And it's called a weldment. I'm going to make it like a weldment just because. And the first thing I need to do is place my truss outlines so that I can work with it. There we go. And I'm just going to put the one in there. And now on each one of those, I can do something really cool. I can go into my design thing and I can insert framing material. Oh, I got to save it. So this is going to be my roof truss. Yep. Now I got a roof truss. So once my roof truss is in there, and again, I'm just showing this to you so that you can understand how we can analyze materials to make sure that our material resources are correct and that they're good. Okay, so I'm gonna close that down. So I'm gonna insert some framing pieces, and I'll do some ANSI rectangles, and I'll say that maybe they're, see what all is in here. These are all pretty. Let's see what those things look like. That's okay. Here, what I want, flat bar. That'll be better. Now I can get some sizes there we go. I'm going to come up here and get a 4x2 just to call it something. Let's see what I can get. Really only goes up to a 4x1. I'll put that on there. And so now I'll put one on there. Look at that. I'm building my truss. Now I have a truss. Isn't that cool? And each of those are a truss piece, but they're really kind of clunky right now. So as an example, this one sticks into the other one. So I have to trim. Trim back to there. I'll trim that one, and that one. Let's see if it'll do those. Let me try that again. Trim, extend. Trim. Oh, I have to select the face. I'm going to select that face, and now I'll select my members. Now you can see those have been trimmed. So I have to go through that and do that to all of these, right? I need to trim them all. So now let me take this next one, trim. There's my face. And then I'll select the members that hit that face. And then I'll trim that one, and I'll trim that member. So you just go through this. Let me get back to my original spot. There we are. There we are. I think I have a few more to trim here, right? So as an example, this one's really weird. I need to trim back to that one. I need to trim that member. And back to that one. I need to trim that member. And you really would have to cut all these. And I can see right there I've got some over. So it's just a little process you go through to get them all trimmed out and correct. I better save this because I've, yep, go ahead and save all those. Because once, if you blow it, then you've really got it messed up. But what I'm trying to get across is that you have the opportunity to really do good analysis. Now I see some more. Those ones are trimmed. Those ones are trimmed. Those ones are trimmed. This one needs to trim. And if I had thought I had enough, I could have kind of done this automatically. Let's see. Looks like they're all trimmed, but these. And so I think these two I want to miter. There we go. Looks like all my joints are made. So I've just designed a truss. And yes, I made it out of steel, but that's just because I know the properties. This could easily be made out of wood or anything else, and you'll see that in a minute. I can choose my materials up here. Let's see if I even can find wood here. So I only have hardwoods, but let's go ahead and put that one in there. Should be able to select that and make it wood. There we go. So now it's wood. It's not the wood I want, and it's not exactly the size I want, but it was an easy pick, and I can actually change those sizes later. And what's really cool is each one of these, I have the drawing for it now. Inventor made the drawing for me. That's a cool thing. So I'm going to save that. Now I get to do an analysis. It's called a frame analysis. And I'll create a simulation. And I'm just doing this off the cuff. I haven't planned it at all, but you can see that's how the frame is set. That looks okay. So I have to fix a couple of spots that are going to be immovable. I'm going to fix this one. Should let me pick that one. There we go. And that's like the wall, right? And let me fix this one. I don't know if I got those straight or not. Looks like it. Looks okay. Now, there's got to be some sort of a load, and I don't know what it is. I'm going to put a continuous load on there, and I'll make that load maybe, I don't know what it should be. 15 pounds per inch, maybe. Oh. And it needs to be on both ends. It needs to be 15 pounds per inch the whole way. And let me do another continuous load over here. And I don't know if that's a big load or not. But now I've got a load. And let's just see what happens to this thing. Let's just see what happens. I can simulate it. Uh-oh, something's missing here. The materials are not defined correctly. Let me look at my materials. Okay, so it didn't have all that in there. So let me go back to my material selection and fix that. I'll put it back at something that it knows. And it does know steel. I'd have to go look those numbers up to be able to get that to work. Now let's see. Why is that still saying it? Darn it all. Let me do a quick save on it. Let's see if that'll come back. Otherwise, I'll have to do another one really quick. Still saying wood. Let me do another simulation. That one's got all the right materials on it. So I have to go back and do that again. Put one there. And I'll put one there. And I'll put a continuous load on that of 15. And I'll put a continuous load there of 15. Yep, that all looks right. And now I'll do a simulate. And let's just see what happens. That would be a structural steel frame. I can make it, and look, it looks terrible. Ah, look at all that. But the displacement is only 5/1000ths of an inch. So this thing can carry tons more of that. This is just a visualization of where it would deform. Okay? And the deformation, the maximum is 0.0049 inches, 5/1000ths of an inch. So I could easily now just keep upping that until I got to a maximum deflection that was allowed by either the architect or the standards. And you could go to the standards and that would be allowed, but some architects like to use less than that. So what might an architect do here if this is way too strong? Now we start talking about material choices. We could go back and use wood or tubing or a different material that is not as strong, we could go back to our work and eliminate like a couple of these struts. We could say, oh well, I can really increase my span. So there's lots of things now. Now that I've got a number that I can rely on, and I can rely on this. These are very, very good numbers. Now I've got something to work with. So that's kind of a cool thing. Right? And it's based on this truss. And so I could go back in and look at that wood. I wonder if they have this stuff for a different wood. Let me see if they have stuff for oak. Well, it sure looks like it has everything in there. Oh, it's because it's got all these different grains. So I could go back in with wood now and pop these numbers in where they were missing. So I do have that information. I'm not interested in doing that right now just because I want to just show you how some things work and be able to show you. Another cool thing, let's see, I don't know which way this parameter will change. See what happens if I change that to 140. Most of it changed, but this one didn't. Okay, so it didn't really quite change properly, so I'll just do a Control Z. If when you're doing your inventor work, you think it through to what is going to mirror and where things will be, you can actually do what's called parameterize when you're doing your sketching and your modeling, to be able to look at the parameters. And those show up here. And so you can look and see where things are identified, where they're not. Like you could set this so that this point is always in the midpoint. You can make this one equal to this one so that you can quickly and easily type in some different dimensions and get these done. So this is when we talk about material resource planning, it's gone far past, oh, it's wood and I get it out of this table and I've got with the grain and against the grain. You do need to be aware of all that, but we've gotten to the point where we have analytical tools, and that's one of the things I'd like you to get out of this. Now, where does this go in your where does all of this go? It doesn't go anywhere. This is just for your information. You don't have to be able to do this, report on it, see it, but if you take our course Design 328, which is engineering modeling, you will be heavily involved in this type of work. And I just think it's good if you've seen it and have some understanding of, why it's done and what some of the capabilities are. So this is a classic case. Trusses can be designed, they can be modified, and you actually have great capability to working on the actual materials. Okay, so there we go. Let me come back over to here. Oop, I went too far. How do I get rid of this? There we go. And I don't need to see the truss outline now. There we go. So let me go back and and review what we did to make that happen again. And it's very much like what we did in Revit. And Revit does have this package in it also, but I'm not too familiar with it. You can do those truss analyses from Revit, but not the way we started the Revit drawing. Revit does have frame analysis in it, which is really, really cool because you can get it right early on in the work. So the first thing you do is you just draw a simple line diagram, much like we did in Revit. And that is how you do it in Revit also. You start with a line diagram. And then you start what's called an assembly, where you place members on each of those. Okay, and each of those members, you can see there, that's an individual drawing that I could go look at right now. And it's got all my end cuts and lengths and where things go. And so I could actually take that to the sawmill and say, okay, I want 2 of those and I want 2 of the next one. I want 1 of those and I want 2 of those. And they would actually be able to make those cuts, and then you would use those splice plates at each one of these to put it together. And it would go together well. So this is a great design tool, and you know that it's going to work. That's the best part of it. You know that it's going to work. Okay. That's really what I wanted to go over. Let me just briefly review. So you can see here, right? These are all pre-cut. You've got the splice plates, not spice plates, splice plates at each location. And you could design that and load it. And you could literally do each one of these. How would you pick which one to use? So I'll put Mark on the spot. Mark, how would you, if you had a bunch of these designs and they all kind of worked, which one would you pick? What would be your criteria? And unfortunately, I'm not hearing you even though you're off. Go ahead and type it in the chat really quick. Just to put you on the spot. And I'm sure your answer will be right, but it might not be the only answer. So as an example, most contractors would say the least expensive one. And that's a good answer, right? Because you want the job, and so you would choose the least expensive one so that you have the lowest cost to your client. Yep, and then Mark says it depends on the interior design, and that can be also, for instance, over here, you see one that looks like making room for an attic. This might be for a certain snow load. This might be, I don't know why you picked that one over this one. It just could be that that thermally this is better. Okay, yes, vaulted ceilings would be as an example. How about another one? So we've got cost, we've got the interior design. What would be another one? Making the guess, or making the knowledge that they both hold adequate load. Well, one of them would be room for ducting. There might be HVAC ducting, there might be plumbing, There might be electrical ducting. Who knows what might be running in there? And so you'll need to know whether you have to have room for a certain size of duct. So as an example, this one, your ducting would maybe have a hard time fitting through those little openings if you had, 8, 12-inch heating ducting to put through. So that could be a problem. It could also have to do with access to lighting, lighting cans, to where you're going to put your insulation. So there is more to it than strength and cost. And that's what makes design interesting, right? If it was all done by strength and cost, okay, an AI could do it like super easily. But we want to be able to do lots of different things and take account many, many, many things. And so you're gonna think about a lot of those. Another one is just availability, right? You go, man, I really like this one. This has the look I want. It's got room. It's got all this kind of stuff. But your local truss manufacturer might not make those. What do you think on that, Mark? Do you have any other ideas?
Can you hear me now?
Yep, I can. Cool.
Okay, I switched headphones.
Yeah.
No, that's it. No. I think I'm good.
Okay. So there's a bunch of different things. You've got availability, you've got cost, you've got another thing is the fire department. Some fire departments require certain types of connections and certain things on the roof. They might require minimum or maximum slope. So there's lots and lots that will go into it. It could be that you're also going to say, hey, I need solar power and I need a certain angle on my roof to maximize the solar panel. So you might put something like this on a part of it to get just the right slope out where you're going to do it. Okay, so this is all kind of cool stuff. This is part of the design, and it's all fed by it's all fed by the fact that I can't see what I wanted to look at there. It's all fed by the analysis, the numbers. You need to be able to check and see that your numbers work. And that is a cool thing, right? Okay, so that's a little bit about this. Roofing systems. Let me go ahead and get back to here. We talked about the difference between rafters and joists. The ceiling is the skin on the underside of the joists. Sometimes you have a ceiling and sometimes you don't. Okay, they call that a wall plate or a top plate, which is what this all sits on. And so lots of cool stuff there. We talked about beams and joists. Bending moments are an interesting thing. This is what that whole VMware was based on. It says I've got 2 points. Each thing has a load, and it's either in shear or there's a moment on it because it's fixed at each end. Okay, so that's cool. You can look at that. You can look at what it means specifically in civil engineering. And then we talked about all of these cool things. So I think that's where we're at. Any questions left that we need to go over? Everybody, are you okay with the Revit demonstration that I did last time? I could do that again if we need to. Okay, well if that's good, and yeah, so yeah, the Tuesday demonstration was pretty good on it, and you can go back through and do that. So I'm going to go ahead and stop the recording.